Good morning, good afternoon, good evening. Welcome to this talk from wherever you're logging on in the world. Welcome to SRE Summit 2024. Today, I'll be talking about a very interesting topic which we're calling SRE Renaissance, Reshaping Operations in the AI World. We'll be talking about SRE, how it has progressed, and how it is getting into a new avatar in 2024 and beyond. What are the context, what are the connotations of it as it moves into the AI world that is impacting everything that we are doing these days. But before I get into that, let me give you a little bit of my introduction. My name is Savinder Puri, and I'm a DevOps evangelist with a bank in Eastern Europe. I work remotely and I'm currently based in India. I started off with my career of DevOps long back in the year 2000, and one of my first jobs, my designation was build jockey, where I used to create software builds. And I come from the era where our builds used to run for about 48 hours on 4 parallel blade servers. And we used to also be called build engineers at that time, because the word DevOps had not even been coined yet. So that's where I'm kind of coming to you from. And over the past about 24 years, I've had the opportunity to work in India, in US, Europe, UK, and South Africa. And I have worked across products, large enterprises, service integrators, services companies, startups, and at one point I had my own consulting gig as well. So I've kind of been around the room for a while. Currently, I'm also the ambassador at DevOps Institute and CDF, the Continuous Delivery Foundation. I also run a YouTube channel where I merge DevOps and spirituality, because I believe for DevOps to be truly successful at scale, you need a slightly spiritual belt of mind. And along this career path, I've also managed to write 2 books. One is to how to build a career on DevOps, and the other one is on spirituality and success. So that's a little bit brief of where I'm coming from. Now let's straight dive into our topic. Now this is one of the very famous quotations about SRE, and I picked this up from Google's celebration of 20 years of SRE. Now, as I'm sure you're aware, SRE, the Site Reliability Engineering concept, and the whole movement started with Google, and for several years it was their secret sauce on how they got stuff done at such a large scale. And in the last couple of years, they've come out and they've open sourced and they've gone public with a lot of their material, with a lot of their documentation. But this is how they initially defined site reliability engineering. They said SRE is what you get when you treat operations as if it's a software problem and you staff it with software engineers. Now, what's the relevance of this? The relevance is that you treat operations as it's a software problem. You don't treat it as an afterthought where, hey, this bug occurred, now what are the actions that I need to do in order to fix it? It's not a reactive thing. What do they mean when they say treat it like a software problem? Meaning they treat operations with the same rigor as you would treat development. Meaning they want to get the same amount of rigmarole in the operations itself and make a shift from reactive to proactive, and if possible predict things before they start even occurring up. And you staff it with software engineers. What's the context of that? That is because to solve these problems in a software parlance, you need a software engineer's mind and not an operator's mind. So having understood this, let's look at a little bit on how SRE started evolving as the time went along. So you've probably seen these books very famous books, authored all by the SRE team at Google. And this is how SRE has kind of progressed from, hey, these 5 services are down, to having a product focused mindset where you're not just saying my services are down or I'm not able to achieve this thing, but you're gone onto a product and you're talking about whether my product is functional or not, whether my product is behaving in the way it is supposed to be from a user's perspective. So instead of tracking individual service and maintaining its uptime, you shift from there to the product's usage from an end user perspective. You shift the focus. And I'll talk a little bit about how Google says that this focus has to be shifted. It starts with engaging with your stakeholders, documenting all the roles and responsibilities of the users and how they interact with the product. Sort of coming out with the RACI metrics. And once you have that, then you see how these different roles, responsibilities, how these different personas, to be more appropriate, how they start using the product. So it comes down to a product registry of user objectives and how they are achieved at a very high level. So these are my 5 user personas. This user persona does typically these kind of actions. This is what their end goal is, and these are the high level descriptions. That's how you start modeling the product. Why do you model it? Because then you have the use cases, and then you want to measure the performance on those use cases. And how do you do that? You define a set of severity and criticality definitions aligned with the product's users' objectives and steps. For example, this page should load in this much time. This service should not take more than 3 milliseconds to respond back. This widget, when pressed, should be able to save all the data in less than 5 milliseconds. Something along those lines. And then once you have those baseline measures of performance, then you manage your reliability on top of that, where you define a prioritized set of product SLOs, service level objectives, that cover different SLO types, ranging from availability, latency, and what kind of instrumentation, what kind of observability will you need from the services side, from the client side, from an end-to-end perspective. So that's how this shift happened from tracking individual services to more of a product, to more of an end user perspective. Now, let's look at some of the challenges that we have traditionally seen in implementing SRE at scale. And these challenges have mushroomed over the last couple of years because now you need to intelligently distill insight from complex application stacks. It's not a 3-tier application that you're talking about with a front tier, a middle tier, and a back end. Now, even that simple application has got 15 layers in it, everything from caching to redundancy to a whole lot of rigmarole brought down into it. And the more complex the technology stack goes, the more difficult it is to distill all the insights from that. And that technology stack is now typically spread across on-premise or managed or private or public cloud environments. And in any large enterprise, your estate, your workloads are typically spread in all those kinds of environments, making SRE more complex because you're adding more layers in the environments. And the goal of SRE, like I said, is to stay ahead of application and IT outages and resolve incidents before they impact users. So you're not just saying, hey, this issue happened, I fixed it in 10 minutes, 5 minutes, 30 seconds. You're saying I have telemetry which is going to tell me that this incident is occurring, and I will do some remediation so the incident doesn't even occur in the first place. That's the goal. Another very common problem when dealing with SRE teams is the constant firefighting, because teams typically go from one fire to the other, and then they don't get time to permanently go in, make corrective fixes, so that at least that, if not the associated problems, do not reoccur at all, because they're so busy fighting all these fires that keep happening. So the SRE teams are constantly evaluating intelligent IT ops solutions to help address these challenges. So here are 5 quick health check questions for your SRE teams for you to figure out what is the tentative level of maturity of your teams currently. So does your SRE model use automation and tools to improve resiliency? Meaning, do you have certain automation which is toolset based, which is improving your resiliency quarter over quarter? Are you taking some steps in that direction? Second thing, are your users satisfied with the speed of incident resolution and operational efficiencies that you're putting in? What's the customer feedback that you're getting? What's the user feedback that you're getting? How quick is the feedback loop? And are those users satisfied with the response once something untoward happens? Are your SREs able to receive proactive alerts, thereby reducing noise and incidents? So we spoke about going from preventive to proactive. So are they able to receive those proactive alerts and cut through the noise and see, okay, that's an alert that I need to action upon, rather than these are just standard alerts that keep popping up in my system and I don't have to worry about them? Do your SRE have intelligent tools to find hidden patterns and context to help isolate problems for faster resolution? Which means, is your telemetry, is your observability so mature that you can find patterns in your logs which will help you isolate the problem and do debugging much more faster? Can you say, tell me where this string occurred, so that you can spot that and potentially catch problems much faster? This is, if you realize, this is going into the machine learning part of things now. Are your SREs able to receive intelligent insights and recommendations into existing ChatOps workflows to enhance collaboration and speed decision making? What's a ChatOps workflow? Let's say you're using Slack or Teams as your communication medium. Is your SRE tool connected to your Slack so that you can say, hey, I found this issue, can you figure out the resolution? Can the insight from observability come directly into your Slack or your Teams so that you can action it, increase collaboration, and speed the decision making? So when you answer these 5 questions, that will tell you if your SRE teams are rising up in the scale of maturity, and are you even thinking about solving for these kind of things. Now let's look at some industry data. This is the State of AI Report 2024, which got released a while back, and it's saying, as expectedly, that the investment in AI is increasing. And here are the areas in which enterprises are investing in AI. They are investing in speeding up development by automatically generating code. Now you've all heard of stuff like Copilot, which integrates with your IDE, which can generate your code given the right prompts, which can auto generate unit tests given a piece of code, stuff like that. Enabling users to easily customize dashboards. Now this is becoming more important because we want to democratize the telemetry and the observability. So users should be able to draw what kind of telemetry they need corresponding to the kind of team and the kind of work they do, and to be able to produce their own dashboards. When I say dashboard, think Power BI dashboards and the ability to customize them at will. Something like that. The third one is enabling users to build interactive queries for analytics. So, like I said in my previous example, using ChatOps, you should be able to write plain English and query the system, and it should be able to give back the results, which again goes into the machine learning kind of areas. Reduce operation support costs by anticipating service affecting issues and enabling teams to proactively resolve them. We spoke about this, right? So those are the areas in which investment is happening right now. The top focus areas for AI right now is automating analytics to handle the observability, security, business, events, data. We just spoke about that. And why do you want to automate analytics? To generate insights. And what happens by doing this is to enable self-service, so that the developers can do observability, can do first time incident respond, things like that, without having to depend on another team. So that's the AI focus areas. Let's look at some more industry reports. This one is for Splunk, and they're talking about artificial intelligence for observability. And these are some of the typical ML techniques that are being used for IT ops. Number one is anomaly detection, where I typically get these kind of warnings in the log, but these two warnings are different. They are not the usual warnings which come out in my logs. So there is an anomaly and I detect it, and I want to see what is happening here. I want to dig deeper. The second one, predictive analysis. I can spot a pattern of what is going on. Initially, this pattern, when left undetected, unattended, in 20 minutes resulted in a P1. Now, when I spot the same pattern in the logs, spot the same patterns in the warnings, I'm able to predict, and you should do something about it. And then clustering different sorts of logs, different sorts of analytics into buckets, and saying this one you can ignore, this one you can look at it in the next 12 hours, this one needs immediate attention because these will cause issues in the next 30 minutes. So these are the typical ML techniques, and we'll dive deeper into a postulation of how to use them, and we'll get into some examples of this as well. So let's look at AI ops and intelligent operations using AI. So how SRE is being redefined now in the AI world. So what are the areas of impact? It's automated incident resolution. It is dynamic capacity planning. So in the last Black Friday sale, I had to scale my infrastructure to 3x. But this time, depending on the sale volume for the last 6 months and depending on the industry statistics, I expect not a 3x scale up in the infrastructure, but a 2.3x scale up, and I will be ready for that. Predictive maintenance, we've spoken about this quite a lot. Anomaly detection and root cause analysis. So detecting where the issue is and going and fixing the issue as well. And then continuous improvement through feedback loops, because this root cause analysis then gets into your knowledge base, which is then fed into the machine learning engine, and your AI system further evolves. So automated documentation and knowledge sharing. Now let's look at an AI workflow for operations. And this is an example of how things could be set up. So you have the SDLC, the software development lifecycle, where code is being created and then stuff is being deployed. So you deploy a product onto one environment, and then you have certain data ingesters on that environment. It could be your Splunk, your logs.io, Fluentd, Logstash, whatever. And all of these are ingesting data from that environment and getting unstructured data populated. And then what you do is you massage this unstructured data and make it a structured data in a data warehouse. Could be on premise, could be on the cloud. Now what you have is structured data in a data warehousing that corresponds to an environment that corresponds to an upcoming release. And then on that unstructured data, you train your LLM. So you say these are the kind of logs that happen when the product is used over 6 months. These kind of entries results in P1, P2, P3s and things like that. So you train your LLM on that structured data. So you do those kind of things which I had spoken about, the three techniques. Normally predictive clustering, that's what is training the LLM on. And then you do the proactive alerts from LLM. For example, the LLM should be able to say that pattern, this one, identified originating from app server, potential issue coming out in 25 minutes. So check that. Or it should be able to say identified this pattern that's different from the last release. However, no change in code for this component. Please check. And how it's able to do that is because it has access to structured data coming from logs. It has access to the SDLC. It has within the SDLC, it has access to what kind of code changes you have made in what component, and the LLM is able to do these kind of associations. And finally, that one issue identified in component 5, an 89% match in component 2 resulted in a P1 2 weeks back. However, this issue is not in P1 in component 2, it is in component 5. But it's an 89% match to the component that resulted in a P1. So check if something's going wrong. So this is a postulation of an AI workflow for operations. And today there is tooling out there to implement this kind of thing. And then what happens is the proactive fix for this goes into production, and then you do a new product release and you retrain your LLM on that. Now let's look at another thing called Cleric. Now Cleric is being touted as an AI SRE teammate. I've personally not tried Cleric and this is not an endorsement, but in my research I found this very, very interesting. And when this comes out, tools of this category are set to redefine SRE and how they interact in the AI world. Now, the way Cleric is explained is you have an engineer here, an SRE, and you have Cleric sitting between your source code, your metrics, your Kubernetes, your logs, your database. So an interface sort of a layer. And let's look at a video that is there on Cleric's website. So they call it the SRE teammate. They triage and diagnose issues in the background. So it's got all of these issues and it's doing the investigation on them. And then what happens is you dig into one issue and you see what triaging it has done, what evidences it has collected, what is the root cause it has figured out, and the root cause is figured out from the Grafana dashboard, Prometheus and the Loki logs. Okay, now let's dig a little bit deeper into all of this. So what you do is you start investigation from Slack, the chat ops I was talking about, and a user says, Cleric, users are reporting intermittent failures during checkout. Can you help me find the root cause? And Cleric then goes ahead and starts its investigation like an engineer. So it's starting getting the context out, it figures the issues, and then it creates hypothesis that there is a memory leak, the service is down which prevents the service checkout, and then it starts putting in the retrieving the logs, the pods, it goes to the logs, and you see there it sees a out of memory error, a Java error. And then what it does is it goes to Grafana, sees the drop there, right? So it's correlating all of this, and then from there it creates the root cause, and then it puts all of this on the dashboard. And then further you can enhance it to go and put in the corrective fix as well. So this is just one example of how these kind of tools are evolving, and tools in this category are set to redefine the way SRE teams function. Now let's look at some of the top challenges affecting successful AI adoption. Now we spoke a lot about AI prompting and how prompts can be set up to define the way you interact with the AI assistant or the way you start debugging it, and the ability to automatically and intelligently optimize AI prompts, even go to the stage of storing the prompts in source control itself. So that's one challenge. The second, and obviously the biggest challenge, is team skills or trainings, because it's a new set of tools, it's a new set of mindset. Then improving the accuracy and quality of the AI ingests, because like any SRE knows, when you ingest logs, it's a ton of crap. So how do you improve the quality of that? Because garbage in, garbage out. Then managing the regulatory risk, because LLMs, you're putting all your data in that, they have to be secured properly, they have to have only your access, all kind of regulatory things. Enhancing the explainability of the answers AI provides. So if any of you have used ChatGPT extensively, you know sometimes it hallucinates. Sometimes it provides answers which are vague, and you have to drill down and get it to a point where you can understand those things. Then the quality of data used as an input for model training. We said logs and the quality of ingest, it's around the same thing, and eliminating biases. This is true for any LLM. You've seen reports, you've seen videos of LLM being biased on certain things. So these are some of the challenges affecting the successful AI adoption. But on and all, if you ask me, the future of AI ops is looking very, very exciting. And we'll see where this future takes on, and then what is the renaissance of SRE in the next couple of months, couple of years in this AI world. Thank you.